Let's talk about two more important parameters, that is half-life and average life. See, when we talk about half-life, very simple, half-life. Suppose say you have some number of atoms in the sample. Now, let's say 100 you have, that 100 should reduce to 50. How much of time is it going to take? That's the half-life. Very simple, correct? Now, formally if you have to define, it is the time taken by a radioactive sample to reduce or decay to half of its original substance or original value. This time is basically the half-life. Okay, so this is a formal definition. In simple layman terms, if suppose say you have 100 atoms, radioactive atoms, it has to come down to 50 atoms. How much of time is it going to take? That basically is the half-life. Alright. Now, formally and mathematically we have to get the formula. Correct. Now, in this case, suppose say T is equal to capital T. Now, N is equal to N naught by 2, half of it, right? N naught by 2. Formula, N is equal to N naught e power minus lambda T. Substitute. N naught by 2 is equal to N naught e power minus lambda into capital T. Correct? N naught gets cancelled. Take log on both the sides. Log of half is equal to minus lambda T. See, when we have log of half, you can take it as log 1 minus log 2. Log 1 is 0, so you are going to get a negative value. These are basic principles of logarithm. Now, log 2, remember this is natural log, correct? Natural log of 2 gives 0.693. So, what we get is that 0.693 is equal to lambda T. T is equal to 0.6931 divided by lambda. This gives us the half-life. That means if we know the disintegration constant for a material or for a radioactive substance, we can calculate what is the half-life. Okay. Now, half-life has a lot of application, we can say, because some elements or some radioactive elements, they have very, very large half-life. Like some of them, like uranium is close to 10 to the power of 8, 10 power 9 years. This is the half-life. 10 power 9 it's very, very long, isn't it? It's almost close to the age of Earth, 10 power 9. Now, there are certain radioactive elements which are like few, maybe less than nanoseconds, like picoseconds are there. 10 power minus 12 seconds is the half-life. Naturally, those kind of elements will not occur. Obviously, 10 power minus 12 seconds is the half-life. That means in 1 second, it would have undergone 10 to the power of 12 disintegrations. I mean, that's a lot, isn't it? So, those we can create in the lab artificially, but naturally they do not occur. Whereas elements like uranium, thorium, carbon, all these things, they exist naturally. That's the whole point of carbon dating, what we do. Okay. Now, these half-life, they are used, one, for carbon dating, to understand the age of the universe. Like, okay, so this element is there, this is the half-life, this is what is the age is going to be. So these kind of things, we use half-life and we figure out what is the age of that particular material. Okay. Now, this is half-life. We have another parameter called as average life. So, average is what? Sum by divided by number of terms, correct? The same thing we apply here also. When we talk about average life is the sum of the lives of each and individual atom divided by total number of atoms. Alright. Now, let's be very more precise in this. We have to talk about the number of atoms present in the sample, the life of the number of atoms present in the sample, to the total number of atoms present in the sample at that instant of time. This basically is the average life. Okay, now mathematically, tau is equal to 1 divided by lambda. This is the average life. Now that you understand what is half-life and average life, let's try to find a relation between these two. See, what we know? We know that lambda is equal to 0.6391 divided by t. Correct? Reciprocate. Because 1 by lambda is tau. So, tau is equal to t divided by 0.6391, or tau is equal to 1.44 T. The average life is 1.44 times the half-life for a radioactive substance. Okay, so these two are quite important to understand about how a radioactive material or how a radioactive element works. Alright, so in the next upcoming videos, we'll learn more about these radioactive substances.